This is Geometry 5.5. We're going to talk about trapezoids and all the properties that we know about trapezoids. Okay, what do we know about a trapezoid? What is a trapezoid? This would be considered a trapezoid. If I can get the yellow and the orange to be parallel to each other, they're not parallel, definitely not. Oh, still not parallel. But if I align them in such a way, they can be parallel to each other. That would be considered a trapezoid. We have parallel sides. This would be a base. This would be a base. That makes these base angles. Those are considered base angles because they're the angles along the base. These are another set of base angles. If these two lines are parallel to each other, we can talk about our card. What if you have two lines that are parallel? If you have two lines that are parallel, then you know consecutive interior angles are supplementary. That's these two. There's your parallel sides and your transversal. So your consecutive interior would be right there. These are supplementary. So if you were to come down here, you'd have parallel. What we typically do for parallel is to draw an arrow. Can't really draw an arrow on this one, but these are going to add up to 180 degrees. So if you know that this is, let's call it 40, then you know that this one is 140. We don't know what this is. This is clearly different, right? It's acute. This is obtuse. We don't know what that is. That looks obtuse. So that's not true. You know these are supplementary also. That's true about every trapezoid. So if this is 120, then you know that this has to be 60. You know, together they have to add up to 180. I'm sorry, together they have to add up to, all of them have to add up to 360 because it's a trapezoid. That's true about every trapezoid. Now, what if we change it up a little bit? What if we make two sides the same? What if we make two sides the same? These sides don't have to be parallel, but they could be parallel. And when it lines up exactly in the right spot, you know that these angles are going to be supplementary just because you have parallel lines and those are consecutive interior. But these are also going to be exactly the same measure. Base angles are congruent. If the legs are the same length, these will be the same measurement. These will be the same measurement. So if this is 70, this has to be 70. If that's 70, this has to be 110. This has to be 110. And together they add up to 360. These are called the legs of the isosceles trapezoid. These are the base angles. Base angles are congruent in an isosceles trapezoid. Even if you turn it sideways, the base angles are still congruent. Doesn't matter which way it turns. The parallel sides are the parallel sides. Those are called the bases. Okay? Then we're going to talk about this midpoint. M is the midpoint, N is the midpoint, and we connect those midpoints together. We get what's called a mid-segment. And we're going to talk about a mid-segment also. So what we know about a kite, we haven't even talked about those yet, and a trapezoid is that they're not parallelograms. Not parallelograms. Clearly not. These two sides are not parallel. Even if it's not isosceles. These are further apart here, but closer together there. So that means these lines are coming together. Not parallel. It only has one set of parallel sides, not two sets. One set of parallel sides. It's a quadrilateral with one set of parallel sides. Trying to make it obviously not the same. Okay? This is considered a base, the parallel side, and this is considered a base. It's the base of the trapezoid. Parallel sides are the bases. Base angle, those two are considered base angles. A different set of base angles would be these two. And I'm going to use two lines to represent my arrow in this case. Those are base angles, like we talked about earlier. You know that these two angles are going to be supplementary. Because they're the consecutive interior angles. An isosceles trapezoid it's a trapezoid, so it has all the properties that a trapezoid does, with one set of congruent legs. The legs are the sides that join the parallels together. That's an isosceles trapezoid. And if that happens, then your base angles are congruent. You have one pair of congruent sides. Those would be the legs. One pair of congruent sides. You have another pair of parallel sides. Now we haven't talked about the diagonals at all. Let's come on back here and talk about our trapezoid. This is just a normal trapezoid. Doesn't quite reach, but notice how that's really long. And notice how this is much shorter. Okay, so they're not the same length. Diagonals are not the same length in a trapezoid. But if you have an isosceles trapezoid, maybe it's a little bit longer than that. This length is going to be the same as that length. That's true about every isosceles trapezoid. The diagonals are the same length. Do the diagonals cross at the midpoint? This midpoint is about right there. This midpoint is about right there. So are they crossing at the midpoint? No, clearly not. Diagonals in a rectangle cross at the midpoint. Diagonals of an isosceles trapezoid, or any trapezoid for that matter, is not crossing at the midpoint for both. So the diagonals are congruent. They're clearly not perpendicular. They can't be perpendicular. So let's take some of those facts. Let's answer question 1. This is a trapezoid. This is an isosceles trapezoid. Because it has the legs the same length. So I know that the measurement of angle B is going to equal the measurement of angle C, which is, of course, 135 degrees. If isosceles trapezoid, then base angles congruent. So our base angles, the ones that are touching the same base, those are base angles. Now we also know that A is congruent to D, but I don't know the measurement of A or D. How can I figure out the measurement of A or D? Are they 135 degrees? Clearly not. This one's obtuse, that one's not. I know that the measurement of angle A plus the measurement of angle B are supplementary. I know they add up to 180. So does C and D. So the measurement of angle A plus 135 equals 180. That makes the measurement of angle A equal to 45 degrees. So D is also going to be 45 degrees. That's true about an isosceles trapezoid. And that's what we have here. Let's come on down and talk about another isosceles trapezoid. AC and BD. Those are called the diagonals because they go through the inside of the shape. If isosceles trapezoid, if a quadrilateral is an isosceles trapezoid, that'd be a great way to write it, but I'm trying to shorten up the words as much as we can here. So if isosceles trapezoid, then diagonals are congruent. If they're congruent, then we know that AC is going to be equal to BD. 9x minus 5 is going to be equal to 5x plus 23. So I'm going to subtract my 5 across to get 4x. I'm going to add my 5 across to get 28 and divide by 4 to get x equals 7. What do we think? All right, we'll flip it over. Here's the mid-segment stuff we're talking about. This will be on your final exam. So what we mentioned is this segment in here, as long as we're touching midpoint to midpoint, it's going to be parallel to the other two bases. That's kind of cool. It's always parallel. It doesn't matter. As long as those two sides are parallel, if we touch the midpoints, it's going to be parallel. So we know that. And it's halfway in between. So if that's 2 and that's 4, then this is going to be halfway in between. The length is going to be halfway. It's going to be 3. It's going to be the average of the two put together. 2 plus 4 divided by 2 is 3. It's going to be the average of them. The mid-segment of a trapezoid is parallel to the bases. So they all are parallel to each other. The length is half, or 1/2, half the sum of the lengths of the bases. So it's parallel to AB. It's parallel to CD. And here's the important part. This is what we're going to use on our exam. Half, the mid-segment is half AB without the line, because we're doing numbers now. AB is the length. So AB plus CD. So to figure out what MN is, I know that MN is going to equal half of PQ plus SR. It's going to be the bases added together divided by 2. So if my PQ is 16 and my SR is 9, I'm going to take half. Now I could distribute that in here, but I don't know what's half of 9. I don't want to say 4.5. But you could. We know that this adds to be 25, and half of that is 12.5. So half of 8, or half of 16 is 8. Half of 9 is 4.5, so 8 and 4.5 is 12 and a half. You could do it that way, but usually we try to stay away from decimals where we can. We took half of it, so we're done. How about this one? This one, they give us the value of MN, but they want us to find the value of x. What would make that x the perfect number? So I should know that the mid-segment, which is MN, is going to equal half PS and QR. So MN is 21. Equals half. PS is 30 plus QR is x minus 1. So how am I going to work with this half? I could distribute it and take half of 30, half of x, and half of 1. You'd have to take half of every single one of them. I know half of 30. But I don't know half of x, and I don't know half of 1, and I don't want to use decimals, so let's stay away from that. We will group the 30 and the 1 together. But first what we're going to do is multiply by the denominator. So when I double a half, I get the value of 1. And I double 21, and I get 42. These You're not going to add 1 to 30, but you're going to subtract 1. They're on the same side of the equal sign, so we just group them together. 30 is a positive number, 1 is a negative number, so that's 29. Then, because we're going to go to the opposite side of the equal sign, we do the opposite of what it is. We subtract it. That gives us 13. So x would have to be 13. 13 minus 1 is 12. 12 plus 30 is 42. And half of 42 gives us 21. It worked out perfect. You can always check your work. It's math. Okay. So let's come on down here to letter C. What do you see? What do you think? So we know the mid-segment is 41.5, and that equals half of the two parallel sides. 34.5 plus 9x plus 8. I don't particularly want to take half of 34.5. I don't want to take half of 9. I'm okay with taking half of 8. But don't do that if you're not going to take half of the others. So we're not going to do that. We're going to multiply by 2 to the other side. That's going to give me 83. The half is gone because I doubled it. Now I have these two to put together, 42.5. And I subtract 42.5. And that gives me 40.5. And then when I divide by 9, we can do this without a calculator. 9 goes into 40 how many times?
4.
Goes in there 4 times, which gives us 36. So 36, how many more do you need to get to 40? So you need 4. So now you have 45. So 9 goes into 45 how many times? 5. And the decimal point is in between. So it's 4.5. You can do these calculations without a calculator. Okay, last one. 20.5 equals half of 27 plus 6x minus 1. Those are the parallel sides. Those are the bases. I don't want to take half of those, so I'm going to double 20.5. That gets me to 41. Group these together gives me 26. Subtract my 26 gives me 15. Divide by 15, and I see 3 can go into that 5 times, and 3 can go into that 2 times. That's 2.5. 5 halves is 2.5. There we did it.